Hi everyone. First, we would like to thank you for your interest in Automation Studio, the all-in-one, user-friendly circuit creation, simulation, and troubleshooting software for hydraulic, pneumatic, electrical, and PLC. In today's webinar, we will go over hydraulic and electro-hydraulic modules in Automation Studio. We will go over basic manipulations. We will create an hydraulic circuit. We'll change properties on some of the components of the circuit. We'll be inserting a measuring instrument, using the plotter, inserting a bill of material and a title block. We will show you how to customize a library that matches your current hardware equipment, or also to simplify the use of the application by limiting students to use only the component that you want them to use to create a specific assignment. We will also create an electro-hydraulic circuit. We will insert pictures beside the components. We will create an electro-hydraulic circuit. We will show you how to create MP4 video format that you can also share with your student or actually upload on YouTube, for example. And we'll finish by also showing you the manufacturer's catalogs that are available for the educational version. Okay, so let's get started. So this is the actual Automation Studio interface. So the first time that you launch the application, it will also start with a white page like that. On this type of document, okay, if I zoom out, so if I go view here, and I do zoom the page, this is your 8.5 by 11 page. Okay, so everything you do here, you're always aware of the space that it's going to take on your sheet. Okay. A bit later on, I'm going to show you how to change this page if you want to be landscape, or if you want to have like 11 by 17, or most of the time what I recommend is to actually play with the scale if you're missing room on your page to still fit your drawing on an 8.5 by 11 sheet. Okay, so we'll go over those. Some of the basic manipulation also are going to be panning, zooming, and we will review those as we build our first circuit. Okay, so let me just zoom back in a bit and move my page. Okay, so right now the library is open. So this is the library of components. So today we will focus on the hydraulic part and the electrical control to do an electro-hydraulic circuit. The components here are lit in the hydraulic section, or some of the most commonly used one that we've put there. But keep in mind that you can always navigate through the subcategories of the library to find much more components that you may be required. Okay, so for now, I'm going to use components from the main section to build my basic circuit. So I'm going to drag a pump here. So the way you drag, it's simple. You just click and you just move it on your sheet. Okay. I'm going to drag now a pressure relief, a double-acting cylinder, and a 4-2 directional valve. So once the components are placed on my drawing, I can directly go, so you see those red dots? These are the actual connection port. And you see my cursor, as I go close to it, it changed as a target sign. That means that you're allowed to make a connection there. So let me just zoom back to everything. Okay, you're going to see me moving around here back and forth, so I'm going to explain right now the short key for zooming and panning. Okay, so panning is to move your sheet. So you can come here in the view menu, panning, and then you can drag your sheet like that to move it the way you want. The short key for that is actually space bar, and you click and you move. Okay, the other important feature is the zoom in, zoom out. Obviously you can click here, zoom plus, zoom minus, but you see it kind of zoom like wherever you want, you know. But the best way to do it is holding the control key of your keyboard and rolling the wheel on your mouse. And the good thing about this zoom is that it's going to zoom where you're pointing your mouse. You see, as I'm going here on the page, it zooms there. If I'm going back at the pump, it zooms at the pump. So sometimes when you have a circuit that you want to focus on a specific area, that zooming feature is very interesting. And then once you want to see all your components, you right click, zoom all component, and there you go. And again, space bar click, I can move my page a bit to the left. So now I'm going to actually build the connection to these components. So if you see when I position closely the target sign, I click, I let go the mouse button, and I click again. A lot of people keep their finger on the button, okay? I'll show you why it's not that good to do. So click here once, click here. I'm going to click here, click here, click, click, click here, and I want to connect this here in the middle of my line. But as you can see, there's no target sign that's showing. So in order to insert the junction, I need to simply double click. You see now I inserted the junction in the middle of my line. And now I'm going to bring this one back down to the tank. But you see, I feel like it's going a bit too close to my pump. So this is why it's good to let go the button, because you see now if I click here, and then if I double click, I'm going to drop the line. And now I can take another reservoir and put it here like this. Okay? If I wanted to, it's Windows-based application, so I could have simply here, copy and paste, and drag the reservoir here. Or I could have simply hit the Control key while moving this. You see there's a little plus beside my cursor, meaning it's going to make a copy. Okay? Keep in mind that if you say you change properties on a component on your sheet, and you do a copy like this, it will copy the exact same components with all the changes that you've made. If you take it from the library, it's going to be brought on your drawing with all the basic configuration that is already made in the application. Okay? So once I've done this, everything seems to be connected. So I can go directly in the Simulation tab and hit Normal Simulation. So as you can see, my circuit come to life. I can see the fluids going from the pump, the reservoir, sorry, through the pump, exiting my pressure relief, which is open. And you see sometimes when you position your mouse on some of the components, it changed as an end sign. That means that you can interact with the schematic. So right now, if I click here, I actually control my directional valve to simulate my circuit. Okay, so it's as simple as that. So you do a schematic. Every properties are preset to work right away, and then you can do your simulation. So now what I'm going to do, okay, I've just got a question asked during the presentation, and yes, this presentation is being recorded. So after the presentation, we can definitely send you a link if you want to share this with colleagues or students, whoever you want, okay? Well, every component that you have on your schematic, if you right-click on it, you can go Context Help to actually see a description of that particular component. And you can cut and paste that if you want to create documents that you can close that. You can also select some of the components like that. You can right-click, copy. I can open Word, for example, and I can simply paste directly into Word. As you can see, the quality is very good. It's all vector graphic. So when you print that out, it looks very professional. So as a teacher, for example, I could have put like some text here, and I could have just come here and select only the symbols. By holding the Shift key, I can make multiple selection like that. Then I could have copy here, go to Word, and paste it like this. And the students have to make the wiring diagram as an exam, for example. Okay, so this is for the cut and paste into Word. I did Word, but I mean you could cut and paste that into any Microsoft application directly like we did. Okay, so we did the ELP, we did this. So now let's change properties on that circuit. For example, let's say that you see when I move the components also, they stay connected. So it's easy to realign your circuit when it's not perfectly aligned. Or if you want to add a component, like now I just put that down because I want to add another cylinder beside it. So that's all, you can just do it, okay? So now I want to copy this cylinder to have the exact same property. So I'm going to copy the one on my drawing. Copy and paste. Now I can connect this one in parallel with the other one. So you see if I click twice here, as you remember, click here and click twice here to link it. So now if I simulate again, they both extend and retract at the same time because they have the exact same parameters. Something to keep in mind also. You see now I'm clicking on the lever of the directional valve. But every time I go to the button, the spring's pushing it back. I want to lock it in place. To lock a valve in a specific position, you need to simply click on the spool directly and you'll see a big check mark like that. This means that the valve is presently manually override in that position. And if I click on the other one, it goes back. And in order to remove that forcing method, you're going to click on the spring or the command here to get rid of it. Okay, it's important because I've seen customers sending me circuits saying it doesn't work, and they were making an electro-hydraulic circuit with a solenoid on it, but the spool was overwritten in one particular position. So even though they were activating the solenoid on the valve was not shifting because there was a big check mark there, and they did not know what it was for. Okay, so keep that in mind. If you do an electro-hydraulic and some students come to you and say, how come it doesn't work? The schematic is well done. This could be a reason, okay? So now I'm going to stop the simulation and I'm going to modify the properties of this particular cylinder. So I'm going to click twice on it. So to open the properties window, there's two ways. You double click or you right click and you go component properties, okay? So I'm just going to double click on it. It's easier. And here I can see all the properties for that particular component. So I can change the extension percentage, the inclination, piston diameter, rod diameter, stroke length, and weight, and things like that. Something important. Right now, you see those fields are kind of like the most commonly used fields, okay? But there's more than that. You see all those yellow stars here? This means that these are favorite fields. If you click on the star at the top here and you remove this, you will now see all the available properties that you can change. Internal leaks, friction, damping coefficient. So there's a lot more possibilities like that, which some teachers may want to hide so students don't see all this, or some others they want them to see. So keep in mind that this star could be the issue, okay? I've had people calling me say, okay, I cannot change a specific unit for a component, and it's because the field was hidden by default because it wasn't a favorite one. So by simply unchecking this, you will display a lot more possibilities, okay? So let's put right now an inclination of 40 degrees for that cylinder. And I'm going to put an external load of, let's say, 5,000 pounds. Okay. You see on the right here, there's some checkbox that are checked. You see that the tooltip says variable is displayed on tooltip. Okay. And on this one here on the left, variable is not displayed on the editor. If I click on it, the variable is displayed on the editor. So you see the 5,000 pound, I check this box, and it will be displayed on my schematic. This is a satellite of the component. So if I move it somewhere else, and let's say I'm going to change the font, so I want to put bold, smaller, and blue, for example. If I move the component, the satellite moves accordingly with it. So if I move the satellite wherever I want, If I move the cylinder, you see it follows. Okay, so keep in mind if you display properties like that, they may not show where you want them to show. You place them and that's it, they're going to follow afterwards. We've put 40-degree angle in the specification and it remains flat here because we follow all the ISO standards. We don't turn components around on schematics. But for teaching purpose, you can go position, rotation, change the rotation point, and actually rotate the cylinder like that. And now the point of putting a weight like this is to actually see changes in the required pressure to push this up. So I'm going to put a pressure gauge over here. I can connect it here. We know that the pressure is always the same everywhere on the circuit, but I could have put the pressure gauge here if I wanted to, no problem. And something important now. If I drag a component straight from the library, I can directly drop it on a line and it will automatically cut the line and make the connection. You see, the dots are black. Okay? And then if I erase it, the line will remain there. Let's do the opposite. Let's say if I just drag it like that here, and then I move it on the line. You see, there's a red dot. That means the component is not well connected. Okay? So that's something to know. Also, another way of knowing sometime you may have an issue is that if you start the simulation and you see a line going through a component like that, this is also a problem. Lines never go through component, okay? They always stop at the connection ports and that's it. So then you know something is wrong. So you can stop simulation. Oh, my dots are red, it's not connected. So I can just take it off. I can delete it and take another one from the library and drop it directly. Or if you hold the shift key down while you move it, it will connect into the circuit. Same thing for the other way around, okay? If, for example, I want to take this and remove it from my schematic, disconnect it. You see, when I move it, it just carries the line with it. So in order to disconnect, if I hold the shift key again and I move it, you see I disconnected it. And this is good, so shift, bring it back. Let's say if I take the cylinder and I want to disconnect it, I hold the shift, I move it, and you see it disconnect. So this is something that it's good to know. If you move components, if they're red, the dots are not red, this could be a sign. There's a pressure gauge here displaying PSI right now. If I want to display something else in PSI, bars, Pascal, or whatever unit you want, I can click twice on it. And you see here where it says pressure PSI, I can switch that to display different units. If you want to put 3 gauges, one beside the other, displaying different units, be my guest, do it, okay? But you can change that if you want, and it will display the unit of your choice here, okay? So let's zoom all component again. And now let's make the simulation of this particular circuit. If I start simulation, you see I have 1160 PSI on my circuit. If I go with my cursor over the pressure relief, you see it changes an and sign. So I can click on it and actually change the cracking pressure live during simulation. Now if I go over my pump, you see there's an and also. If I click, I can also change the displacement of the pump and the speed of the pump, which will affect the flow. So if I reduce the speed, you see my flow is going down as I reduce my speed. So it's good to show students sometimes the effect, you know. Okay, what if my pump is smaller? What if it's turned slower? What's going to change, the pressure or the flow? So there, when you do it live like that, it's very easy to view. And now since I have about 14 GPM now, I'm going to simulate again the circuit and see what's going to happen. So let's focus on this part here. So if I start simulation, the first one extends at about 15, 16 PSI. The second one requires about 280 psi to push the weight up. And when they retract, this one gets pushed by the weight coming in first, and then this one comes in. Okay, so this is why creating these like that enables you to, every changes that you do, if you put the throttle valve in here and you close it, you will slow down, you will create a back pressure, you will slow down the speed. So, you know, Automation Studio is very flexible, and it enables you to adapt the software to your current curriculum, okay? So if you have curriculum, if you have labs that you've created your own, or labs that match your equipment, or books that you're purchasing, you can reproduce these labs in Automation Studio. And if you have issues reproducing these labs, or whatever reason, please don't hesitate. Always contact us. We're there to help. We're going to help you, and it's a pleasure for us to know that you're going to be happy with the software and you'll be able to create what you want. So please don't hesitate to contact us, okay? So now you see I've inserted a pressure gauge, a flow meter, but these are components that I had to add on my drawing while not in simulation mode because I was actually editing my circuit. But let's say I want to analyze what's going on during the simulation. So let me zoom in and get a bit more here. Then I'm going to go into the Simulation tab, and you see these three tools here. Component Dynamic Measuring Instrument, Node, and Differential. I'll show you how those work. Those could be very interesting. If I click, for example, on the Node one, you see if I click once, my cursor change. And you see when I get close to a node, there's a little target sign. How this works is that it needs to connect this element to any connection point on your drawing. So let's say if I come here, I click on my left button of the mouse, I hold it down, and when I want to drop it at a certain place, I let go. Now this tool enables me to display at this port the pressure, the temperature, the viscosity, or density of the oil. Okay, so let's just keep it at pressure, keep it simple. And here I could also choose different units. So let's keep it PSI. So you see it reads the pressure right away in simulation. Let's do it again, but this time I'm going to display the bars. So I can see the same pressure reading at that location, but two different units. And while I simulate, you see they will automatically update at the same time. So this one goes on a connection port. The first one here, it's on components. So if I click on it, you see my cursor changed again. Let's say I want to display a unit on my drawing from that cylinder. First, I have to click on it. You see now it's purple, showing that it has been selected. And then I'm going to do again like I did. I'm going to click, drag. I want to drop it here, for example. And here I can display on the schematic directly all these properties. Linear speed, linear position, output signal force, speed, piston side pressure, rod side pressure, whatever you want. So let's show the linear speed in inch per second. And you can always adapt also how precise you want your reading to be. Okay, let's say 2.1. And then I'm going to do OK. So when I simulate again, this one extends about 4.5 inch per second. Retract 6 inch per second. You see, I don't like where it's placed because it's too close. I can take it, and if I go on the corner here, I can just move it at a different location on my drawing. It's a bit too big, no problem. You can go edit, and you can shrink the size also. Everything in Automation Studio is configurable. Okay, we have standards for everything. If you don't like the color in simulation, if you want to reduce at what level of pressure the line will turn red instead of blue, if you want to create different threshold of pressure to show, these are things that you can all change in the settings of the hydraulic, okay? So I'm going to show you, oh, sorry, I forgot to show you one very important also. So you see, for example, if I want to show the flow in this line here, I'm going to have to use the one on component, click on the hose, it's purple, then drag and display the pressure loss or the flow. And liters per minute, no, I'll take GPM. There you go. Okay. Now also, let me take this one off. You can also show the differential pressure. This is the one with the two nodes here. So if I click here, you see again, my cursor always changed to tell you what you have in hand. This one works a bit different. This one, I'm going to go on a node, click, drag it wherever I want. And then I still have a node to go place because it's differential. So I'm going to place this one over here. And I'm going to display the differential pressure. So right now I see that I have a difference of pressure of 0.16 psi between this point and this point. So in this hose, I'm losing 0.16 psi. But what happens if I increase the flow in my circuit? So if I click on the pump and I modify, let's say, the speed, you see the flow going up and my pressure drop also increase with the flow. So all those things, again, like we talked before, it's good to illustrate what does certain action will create on the circuit. And if I stop the simulation, I can click twice on this hose to specify the length of it and the diameter of the hose. So if you want to create a circuit where you have, let's say, 3 hoses, one of 2 feet, one of 10 feet, and one of 20 feet, you can actually show your students that you'll need more pressure to push you all through that hose because of the restriction, which sometime on the equipment can be hard to do because you're limited to what you have, okay? So this is the manipulation tool of some of the equipment that we have here. Another important feature is, let me erase that. And you see it's easy to just click on it and delete. So you can take them off. Now I'm going to use also the plotter. The plotter is a different way to trace curve of what's going on in simulation. So for example, how it works, it's very simple. You click on the component of your choice. You drag it on this plotter. And once you let go your mouse button, it's going to ask you, what do you want to see? I want to see its linear position, for example. I'm going to click on the other cylinder here. I want to see this one, also with linear position. The pressure gauge, I'm going to drag the pressure gauge here. And I want to see the pressure. So now, if I simulate again, I actually have a reading now of what's going on in the circuit, but plotted on this plotter. I'm going to go back down, and it's going to go down like that. And once you finish your cycle like this, you can stop. You can bring this up, make it much larger. You can insert here a legend that will explain to you which line is which, and you can highlight them like this by going over. You can hide some lines if you want. And if you click on that cursor here, the red line, this will bring a ruler like this. And wherever you position this ruler, you're going to see the reading at this precise location. And if you take 2 rulers, the second one will display the reading at that location and the delta between this reading and this reading. So if you want to see the difference in pressure or time that it takes to go out, you can take all those with the differential pressure, with the delta here between the 2 lines. Again, this plotter can be exported to an Excel file, so you can analyze the values or create a graphic in Excel. And you can simply also cut and paste that directly into Word, PowerPoint, or any other Microsoft application. Okay? And by the way, this plotter, obviously, if you want to change the colors, the line, you click on that little arrow on the right, and this is where you will find all the properties of the settings of your plotter here. So if you go here, you can change the background color, you can change everything, okay? Let's close this. So now we have a circuit on our schematic, and if I want, I can also insert directly. If I go home, there's a BOM here. I click on it, I do a little square somewhere, and this will actually compile the information I have on my drawing and generate automatically a bill of material on my circuit. So you see the bill of material is over here. It's quite too big, for what I need. So I'm going to right click on it and go unlock the editing mode. So here you see I can shrink the columns like that, make it a bit smaller. I can also click twice on it to change the font size, the font color, which field I want to display, and this is fully dynamic. So if I drag, for example, an accumulator on my schematic, you see it automatically added to my bill of material. And if I erase it, it goes away. Okay? If you go here also, we have references just above the BOM here. This is how it works. You click on it, and you see my cursor again changed. You see when I go over components like that, it highlights the component. So let's say if I click on the directional valve, and then I click and I drag, so I can identify like this component on my drawing. And if I go in my BOM by double clicking on it, I can choose the fields that I have, and then I can add the fields for the references. And I'm going to have all the little balls referenced right here beside it. So this is where you're going to go here. You're going to change your standard. You're going to change the fields, the grouping, the layout, the font size, how you want. Everything is configurable in that window. Okay? And then you can also just very simply just delete, remove it like that. Another important feature I want to show you that's not mentioned pretty much nowhere is that you see right now my drawing looks pretty good on my sheet. It's not too big or whatever. But let's say if I duplicate this, I'm going to hold the Control key and drag it. You see I'm kind of losing space here. It's too big, so I don't want to have to move my components around to generate some space. I just need more space. So instead of changing the page size, you can right-click on the white space of your page. You go Document Properties. And here you're going to go down and you're going to change the component and drawing scale. This is the best way because when you modify the scale, every component you will bring will be to the new scale. So let's say I put 75%. You see now it fits perfectly in my page, and it's still an 8.5 by 11 page. And trust me, I mean, if you go here and I put it to 25%, I mean, I can do a pretty big circuit that's going to fit on my 8.5 sheet. Okay? Obviously, it's too small, but I'm just saying that if I zoom in and if I drag another component, you see it brings it at the normal size also. So let me just go back. By the way, we have the possibility to undo things in Automation Studio. So if you go in the View tab, Edit, okay, there's arrows here. You see Undo. You can click here to go back, or Windows-based, Control-Z, 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 Control-Z. And you see this is one more time. This was my original size, and back, this is my 100%. So if you make moves on your drawing, on your schematic, and you say, oh boy, it's like, I think it can go back up to 20 moves. So this is good to know, okay? Now, I need to show you the best feature, I think, of the software is actually the customizable library, okay? I know some of you have posted questions, but unfortunately, I will not be able to answer them during the presentation. Please, if you can send these questions after to me by email, I will answer them. Or at the end of the presentation today, we'll spend some time to go over those, okay? Okay, so that's it. And one person asked me just quickly, I just looked at it, says if all the modules are as good as this one, yes, they are, okay? And, so I just wanted to let you know. Okay, The library, again, is pretty big. If you go to our actuators, we have single acting, double acting, telescopic, brakes, mechanically links. It's overwhelming for students sometime at the beginning because they don't always think that they will have what they need here, so they need to navigate, and they're going to spend time, they're going to waste time, and that's not the goal here, okay? We have a search feature, obviously. If you look, let's say, for sequence valve, you see you type sequence, then you go hydraulic, and it's going to direct you to the sequence valve that we have, okay? But I'm talking a bit even more simple than that. So let's say if I click on this book here, new library, okay? I'm going to save this, let's say, right here, why not, okay? And I'm going to save this as training library. You can give it any names you want. You can give it the name of your school if you want. You can give it your own personal name. It's really up to you. You see now the library is empty, but I still have access to both. It's a different tab like that. So in here, I'm going to click on this icon to create a category. And I will call this, let's say, hydraulic. Then I'm going to create a subcategory to hydraulic. So while it's highlighted, I'm going to click on this again. And I'm going to call this Lab 1. If this is your Lab 1, all you need to do, you take the component and you simply drag it like that on the library. So you will generate a library like this that matches exactly the assignment that students need and the components that they need to use to create that particular drawing. If you see this one, we've changed it. We've put a 5,000 pound on it. We've put an angle on it. If I drag it in the library, it keeps its same properties. You see, if I drag it out, it's going to have the same properties. And I can rename it here. If I right click on it and I do rename, I can put here, let's say, 5,000 pound. So I can have one of 5,000, 10,000, 15,000, and have the students experiment, okay, what's going to change, you know, what's going to happen if there's more load to it, okay? So you can put that here. You can take a group of components. You can group them. And when you drag it in here, it brings the entire group as one component that you can also rename. For example, let's say, okay, sometimes I do this circuit like that and teachers say, I don't like that the drain is on my pressure relief like that. I want everything to go back down to the big reservoir. Okay, so we can delete this, and delete this component. Oh, it wasn't. Let me just ungroup it. Ungroup. So I can just erase my pressure relief. I'm going to come here. I'm going to take in my hydraulic, I'm going to take a reservoir, and I'm going to take a multi-port reservoir. I drag it out, and then automatically the software asks me, okay, what's the properties? And you see how many ports do I want? Right now there's only one. So let's say 8 ports. Hold on, my numlock was not on. 8 ports, okay? So just one question here, just a little input. You see the infinite volume that you see here? This means that if I want to simulate temperature in a circuit, I really need to put that to false because I don't want to have an infinite volume. I want to be able to specify that there's 25 gallons of oil in there or 5 gallons of oil because I want the oil to heat up. Okay, so this is something to keep in mind. If it's infinite volume true, that means that it will just keep going. Okay, I'm sorry about the phone. It's working from home. So 8 ports. So you see this now, the reservoir. I can drag it down here, and now I can connect this. Let's say I'm just going to move my pump a bit like that. You see now it's connected to these 2 ports. By the way, if you leave one port open in Automation Studio, once you launch the simulation, the open ports will automatically be plugged. Okay, so if you don't, for example, okay, let me show you one quickly here. If I delete this and I simulate this circuit, you see it's not going out because there's no place for the oil to go back. And I have no pressure relief, so it went right up to 30,000 psi because my pump is like, this is the properties inside, okay? So that's why if it's not connected, it acts like there's a plug to it, okay? Then I'm going to go in my pressure valve. Then I'm going to go into my pressure relief valve. Pressure relief with tank. Look how many pressure relief we have. Because we work with the industry, we need to accommodate the needs of different ISO compliance components, some specific. So you see, this is why it could be confusing for students. There's so many choices. But if I take one like that without a drain, I'm going to drag it. I want to flip it. So I can go here, position, flip it like this, vertical. Or I could have just right-clicked on it and go transformation and do the same thing, okay? So I'm going to connect it here. And I'm going to bring this one back down here, oops, to the tank like that. So you see the circuit's going to work the same way. It's working well now because everything is connected to the tank. But for students, it could be easier like that to realize that everything goes really back to the same tank as having different tanks everywhere, okay? You see here, if I click on a component like that, it's a pressure relief valve. I can also decide to display on my circuit the cracking pressure. Because now, you see, when I simulate, you see I have my cracking pressure here. So when I simulate and I modify the pressure, you see it's going to always display on my circuit. Let's see if I put 1200, it will display directly there the setting. Okay, so this is something that you can also do. That's why the library is good, because you see, if you tell your students go to take a pressure relief, it's gonna be like probably lost in there because there's too many. Okay, so with that library, what you can also do is you can put pictures beside the symbol. So let me open one that I did to show you. All on here. If I go here and I go picture, you see I've put pictures like that beside the symbol. With the COVID situation, a lot of people are teaching online some technologies like hydraulic, which could be complicated, okay? So by using these pictures like that, it helps students understand how it looks like in real life. And it could be pictures of your own equipment. So when you come back to class, the students will know, okay, this is the component because I've seen it before, because you've seen those pictures, okay? And how you put these pictures there is very simple, okay? Let's say I want to take a picture, a cylinder, make a copy like that, and I want to put a picture above it. If you take a picture with your phone, obviously, you can save that picture on your desktop and just go, you see, if I go here, home, I go picture, I do a little square, it's asking me where's the picture. If I go on my desktop, let's say a cylinder picture. It opens up. It's way too big, so I can shrink it like this. I place it wherever I want. And then I can select this, copy, group, I want to group it. And then I go in your library and I drag it here with the picture on it, and I can rename it. That's how easy it is to work with that library, and it makes it so easier, okay? So putting pictures like that really helps to do those things. Oh my God, the time is going really quick. Okay, I'm really sorry. I took a bit more time than I expected. So I'm going to do now an electro-hydraulic circuit very quickly, okay? So let me erase that, because I want to keep just one cylinder for the electrical part, okay? I need to have a solenoid on that directional valve because I want it to be controlled by electrical. So I can go here, I go in directional valve and try to find one, but I may not have the exact one that I want. So to change the directional valve, it's easy. You simply double click on it. If you click twice on it, this opens up. You go to technical specification, and here you can create any types of directional valve that you want. I mean from 4 to 13 ports, many positions. You can, you're going to tell me this is crazy, but I've seen valve with 13 ports and it was kind of crazy, but it exists, okay? So, but just for now, let's keep it simple. So I'm going to click twice on that lever, and that's going to open up the command selection window. So here you can put whatever command that you want. So right now I'm going to need to put a solenoid on it. So I click twice on the solenoid, and you see it's way off here. So I can just move it where I want. It doesn't affect the simulation. And now this is the valve that I'm looking for. So if I click here, but before I go out, I want to show you something else. If you click twice on the spool, same thing, you can choose from a variety of different spools to put on your directional valve. Okay, so let's keep the spool that we have. Okay, and now I'm going to actually create an electrical circuit that will control this valve. So right in that same circuit, I'm going to come here in electrical control GIC, and I'm going to drag and drop a 24 volt source, a 0 volt. I'm going to take a normally open push button. I will drop it here and say this is going to be my start, let's say. Then I'm going to put a relay just to show you how it works. So when I drop here, it's asking me for a name. So let's call it, let's say, CR1. You can put any names that you want, okay? It doesn't matter. Then I'm going to put here a normally open contact. The software automatically asks me to which relay do I belong. So I want to link this to my CR1. So the way it works, you simply come here and then you filter this for C, and you see CR1 is here. You simply double click on it. You see the question mark on the left? If I double click on CR1, it puts CR1 there, and on my drawing, it also has named CR1. I'm going to put a solenoid here, and I'm going to call this, let's say, A+. So let's connect this together, like this. And now I need to associate this A+ to this solenoid. So if I click twice on it, I'm going to filter this time for A because it's called A+. And you see my A+ is here. Click twice. And now the link is made between this. And if I simulate again, I have now an electro-hydraulic circuit. As simple as that. And you see every time I go to the push button, the spring is pushing it back. So I actually need, if I want to push once and it goes all the way to the end, to put a wire here to latch CR1. But then let's say I want it to retract automatically when it reached the end. No problem. I go on hydraulic. I'm going to take a proximity sensor. I'll put it here, and I'm going to call this, let's say, A1. And I'm going to go back in my electrical. So you see how I go back and forth in different libraries like that? So that's why if you create your custom library, here you could combine the electrical control and the hydraulic in the same section. So students won't have to go back and forth like that, okay? And I'm going to go into electrical control, and I'm going to take a normally closed proximity switch, drop it directly on the line as we saw before, cuts the line, and now, oh, sorry, this is a contact, not a good one. Sorry, it's a proximity. Here, a limit switch. So that's what I need to take. Sorry about that. When I drop it, there's a question mark because it needs to be connected to this one. Click twice on it. My filter is already set to A, and you see my A1 is here. I can simply click twice on it, and now if I simulate again, push once, signal is maintained. As soon as I trigger A1, it retracts. Okay, so now I've took a bit more time than I wanted to, but I'm going to be opening some demonstration files for the next 5-6 minutes to show you priority valves, more advanced hydraulic circuit, temperature circuit, and things like that, just to give you an idea of what can be done. Because this is pretty simple, but it's straightforward, it's quick, and it's easy for everybody to use. But then I'm going to show you more advanced, okay? So if ever you need to go, because we have said, I told you it was 45 minutes, I will be recording also the session where I'm going to open demo files. I'll be sending that to you after, probably to the end of the week, okay? And if you have any questions or comments on what you've seen today, please send me an email. You will get an email in about an hour after the presentation asking you for some feedback. These feedbacks are really appreciated, and they help us just to improve our next presentation. And if you want to have more training like this on a specific part of the hydraulic, please mention it as well, and we can maybe schedule another one later on with a product specialist in hydraulic, which will be able to show you much more advanced possibilities, okay? So thank you for the one that have to leave now, and for the other one that stays, let's open some demonstration files, okay? So I'm just gonna I'm gonna save this. Oh, by the way, if you want to save project, it's very easy, save or print. You click on this big logo on the corner, and then you go project, save project as. So let's go on my desktop, for example, and let's call this circuit 1A, for example. And now it's saved, okay? Same thing, if you want to print the circuit, you click on that logo, you hit the print button. If you want to send the circuit by email, you click on this logo and you send it by email. Something also that I forgot to mention too is that you can record your screen. If you go to Tools, there's a recorder here. Record option. You can record your entire application or simply the white area of the circuit. And you can also record your voice as you're recording. So if you want to do a circuit and explain to students what's happening here, it will create an MP4 video that you can upload on YouTube or wherever you want. And then the students can always refer to it to remember some of the specific things that you mentioned, so you can record yourself, okay? So let's open some circuits. So by the way, the circuits that I'm opening, they come with the software. So if you don't have those demos, you can send me an email and I can forward you these demo samples, okay? So let's open something just saying, for example, the possibilities of like an angle with cylinder. What I did here is I did a cylinder with a little animation that lift up, and I can change the piston diameter. This is what's inside the cylinder, but I can change the weight and the angle. So for example, right, let's say I push 10,000 pounds right now, flat. Almost no pressure is required because the weight is like floating in the air right now, okay? There's no friction, nothing. But as soon as I put some angle on it, then the weight is going to take an effect. And if I push it now at 33 degrees, for example, I need about 1,000 psi to lift that weight. Okay, so this is just a little demo I did like that, just to show the difference of lifting different weight at different angle and how much pressure it's required. Okay. Let's open one that shows, for example, some of you that teach hydraulic teach industrial hydraulic, okay? But some of you may teach heavy equipment. So a circuit like this, for example, where we have a priority valve with a steering wheel of a loader, for example, okay? So this is a circuit that actually shows the priority valve. So this here is a Danfoss priority valve. Oh, I even forgot to show you the catalog manufacturers. Okay, sorry, I'll show that to you after very quickly. So if I simulate here, okay, so when I launch a simulation, you see right now I'm lifting the boom, but as soon as I turn my wheel, all the flow is going to go to the priority, which is the wheel, and then it's going to go back to lifting the boom when it's finished. So I can identify one system over another which has priority, and you can actually show it here with the simulation, which sometimes could be hard to show on the equipment itself, but in Automation Studio, you can do it like that, okay? You see like the Danfoss valve that's here. This comes from a manufacturer's catalog. For all of you that have the annual maintenance on your licenses, you have access to these catalogs, okay? Let me show you these catalogs if I go on the website very quickly here. These are the catalogs that we have, okay? So if you go manufacturer's catalog, so you see we have those manufacturers from which we have catalogs of parts, that are already made to simulate exactly like in real life. Okay? And these catalogs were made for the industrial customers, but being a school and having access to everything, you get that. So if I go, for example, home, and I do Catalog Manager, this is where you would actually download the manufacturer's catalog, okay? And then for every component like that, we have a picture. And we also have a document in which we have a circuit that shows that circuit in animation. So you see the priority valve that I just showed you come from here. That is the component that I just dragged out on my schematic, okay? So so we have, let's say if you go to Eaton directional valve, size 3, manual, you see, there's a bunch of valve here. And all these valve, we have the properties are already entered to behave exactly like an Eaton DG17V-3-0. Okay, so these catalogs are ready for you to download, and then you can use. If I want to use this valve on that circuit, I simply take it and I drag it on my circuit like this. And you see the part number is there. If I click twice on this valve, you'll see the work that's done behind this is quite impressive, because we have entered all the area flow of the valve according to this manufacturer's specification. So that's why it behaves exactly like if you purchase the bra. So I'm sorry I didn't have much more time to show the catalog, but keep in mind they're accessible. If you want, you send me an email, I'll send you the link for it, no problem. It's accessible. And again, for the hydraulic, one more circuit. I could have shown you so much more, but let's say I'm going to show you like an e-transfer. So what you can do with the software also is you can have two systems on the same page working at different parameters. For example, this circuit runs at 77 Fahrenheit, and this circuit runs at minus 13 Fahrenheit. So if I launch the simulation, you see this one runs at about 31 psi, but while this one runs at 67 psi. Because it's cooler, it needs more pressure to push the oil through the system. The viscosity of the oil is much higher, and the temperature, as you see here, it's lower. If we focus on this circuit, for example, if I close the throttle valve, you see that I'm creating a pressure at the entrance. And you see now the temperature is almost 2 to 3 degrees higher at the output of my component, which is going to reduce the viscosity of my oil and increase the flow over time. And then if I go through the cooler, I'm going to start cooling down the oil. So I know that in hydraulic system, a lot of the problems are caused by either pressure drops or temperature. So sometimes you may not have the equipment to show this, but having Automation Studio, you can take 5 minutes like that and explain to the students what causes heat in a circuit while by closing a hose like that, or putting a lot of flow through it and things like this. Okay. Can we customize our oil sample? Yes, you can change your oil. Okay. Let me just show you. If you go tools here, you got fluid. You have fluid line manager. Okay. If you click on this here, this opens up here. So you see we have a bunch of oil that we've entered up here, okay? And for all these oil, we have entered the properties here for the simulation, okay? You can add oil if you want. We have that for the gas material also. Rusted steel, rusted cast iron, because it changed the roughness. So if you want to use a specific type of material and show what's going to happen in the pressure drop, you can do that as well. Line type, hydraulic line. So yes, you can change the oil type that you're using in the circuit and see the differences. That could be done. Thank you very much again to everyone for being here today. If you have any other questions or comments, please don't hesitate to send us an email. You can visit our website at www www.famictech.com/edu to access the educational portion of our website. So thanks again, and have a great day.